Thank you for coming to our Senior Design Conference. We are the Autonomous Snowblower Group, sponsored by Dr. Lecture. First, I would like to briefly showcase our team. My name is Connor Long. My name is Dawson Wade. I'm here Boley. I'm Ryan Downing. Boley Carls. All right, going into our introduction and our motivation for the project. Our project is to take last year's snowblower and enhance it to be autonomous. So we're going to clear a rectangular space in Dr. Lecture's driveway. As for the motivation, moving a snowblower in slippery conditions could be unsafe. Therefore, a snowblower that could effectively clear snow while lowering the exposure of harsh weather conditions was our motivation for this project.
So the main goals and objectives. The main goal here is to clean a rectangular area of snow autonomously. I believe tentatively we have decided to test the AV parking lot of the facilities there. So our first objective is to have consistent performance with the positional monitoring the entire operation of the snowblower. The second objective is to use hardware that is compatible, and so we can have multiple paths planned out. So potentially, Lecture can recoup some of his investment by leasing this to his neighbors. And objective 3 is implement stops to ensure safety of those who are around the snowblower. And a bit of our quick overview of the state of the art. That over there, that yellow thing, that's a Yarbo. It's a larger yard care service product. You can put a bunch of things on it. They try to sell it as everything in one. You can put a lawnmower, weed whacker, edger, trimmer. Obviously, that's not our objective. They use GPS cameras and movement sensors. And then over here, this is a video of us operating the current product with remote control. It's a skid steer mount plate. It needs control improvements, and it's hydraulically driven kinks.
Alrighty, so next up are design solutions, basically how we're going to solve this problem. The first thing we're going to do is improve the hood design. Right now there's 16 screws around the top to take the hood off, and that's kind of annoying. So we're going to make a design with gas springs, hinges, and latches, so we can easily get into the terminals, and that'll help with when we're putting our autonomous system in.
Okay, so right now, the electrical wiring of this thing's a little bit of a mess. That right there is on the battery. That is not something we want. This is the electrical board right now. Just a bunch of gobbledygook, really hard to understand. And this is the internals, so it's really hard to trace wires. So this is the thing where we want to invest in better cable management and hopefully improve safety with things like the spidering on the positive terminal of the battery. And this is a wiring diagram. Lots of wires, very messy, but this has helped us a lot with understanding what goes where. And then improvements on the exterior. I don't think we included a picture of it, but the wires going up to the blower, the actual blower head, they don't look like they're very well waterproofed, which is a big issue. And on the other side of the electrical box, waterproof is also an issue. So those wiring connectors that are hopefully more waterproof, stronger, will improve the reliability, as well as wire looming on the inside, as well as wiring tracks to improve the organization of the wires.
All right, so we mentioned that it's remote control. It's kind of remote control poorly right now. Instead of using like a drone control board, they literally programmed an Arduino to read all of the input pins and then map that to digital pins out. Reinventing the wheel in terms of RC. So we're switching this over to a drone control board. They all support ground drones as well. It's just they're used less for that. So ArduPilot is a Arduino microcontroller based drone control board ecosystem. It's an open source thing. There's like dozens of manufacturers that make control boards. We are going with Pixhawk. They are one of the good ones, basically. We did a whole bunch of decision matrices to look at overall ecosystems, controller compatibility, customer experience, and like other sensors available. And their ecosystem's the best. We're planning to use their 6C board. The thing about Arduino pilot boards is everything from here down is standardized. It's just how they implement the software control that's different. And then, like I said, Pixhawk and Arduino Pilot have been used for tons of ground drones before, including tank tread ones. So these are just a couple examples of tank tread robots from online found early on showcase. Then on the Arduino Pilot topic, it's extremely well documented, both with quadcopter sense and the ground rover sense. So there's tons of documentation on how to set this up. And reading through these startup manuals and operation instructions has been very helpful in identifying problems people run into, reasons to mount things in certain ways, and just generally figuring out how to design this.
And so to map where we're going and all this stuff, we need GPS. So we went with RTK GPS. Not a very well-known topic, so I made this diagram to kind of explain it. RTK GPS uses 3 points of interest: the RTK base station, the RTK rover station, satellites. Basically, the base station is on a fixed mounted location, and it'll sit there for 30 minutes while calculating its location based on the satellites. And then when you want to run it, it connects to the rover via telemetry radio. And the rover also gets its connection from the satellite, but the base station will send correction data to narrow it down so we're able to get that zero level accuracy. As we go to our position sensors, as we'll mention in the Pixhawk 6C, it also comes with gyroscope, accelerometer, and manometer readings, helping us get a more efficient location. The RTK base station we decided to go with was the Mosaic H. It's a dual antenna radio satellite connection. Both RTK stations will come with telemetry radio we will purchase. The Mosaic H is going to be really useful for getting around any trees, coverages, houses that are in the area to give a strong connection to the satellite, getting a more accurate, constant accuracy. The rover station we went with was the Drone Cam F9P. We will actually be purchasing 2 of these. This will give us the ability to add heading and yaw. It's going to be very important that we're driving away from the neighbor's car and not into it. We also catted up mounting. It is very important. We have to keep 2 foot distance between these stations to not have interference.
All right, going on to the safety features, we have 4 safety features. First is Arduino Pilot features and systems makes it so once the snowblower goes out of a certain zone or space, it will turn off the machine. Next, we have LED lights, which will help navigate the snowblower, and then we have a hazard light, which activates and flashes once the machine is on and operating. And lastly is e-stops. There's 1 e-stop on the lid of the snowblower right now and 1 on the right-hand side of the wire box. And we also plan to put an e-stop on the controller so we can always turn off the machine at a safe distance.
All right, so this is our block diagram, the electronics schematic of the overall system. So I added a bunch of pictures to this for ease of your guys' understanding. So at the very center is the 6C. This is the control board that interfaces with everything. So its control pins are GPIOs, just like a regular Arduino. So the hydraulic part of the snowblower, the actual tracks, are just simple servos that open and close hydraulic pumps or valves, 2 pumps. So that's how that works. Last year, they used a bunch of individual 12-volt solid-state relays. They're about this big. One of them got burnt because they wired it incorrectly, and they're just generally too large for what's needed out of them to like power simple linear actuators and LEDs. So we're going to switch this out for a more normal, like small compact robotics PCB. We can fit it in the waterproof enclosure as well. So that'll simplify this a lot more. And then up top is the drone, the snowblower side of the GPS autopilot stuff. So the GPS is one of them you configure as an actual GPS. The other one you configure as a compass. And part of the reason we have to mount it so high is to get around metal interference. because the snowblower is made of steel. Then, obviously the hardware e-stop will just kill the machine. The controller e-stops, we can set it up in a bunch of ways. You can map the switch e-stops to stop functions from running, like a switch that stops the snowblower auger from spinning, or a switch that also stops everything running entirely. And on the right-hand side here is the link to the existing RC remote control. All this stuff is compatible with your typical RC equipment. And then this box is generally what would be in Letcher's garage or just outside his front door. So the base station, the telemetry link for correction data, and the laptop that runs the ground control cell.
Now, to run all this, we're going to be using a Windows-based software called Mission Planner. It is actually compatible with Pardue Pilot, making it really easy to get all of our electrical objects into it. Basically, start it up, you have to configure all the electronic parts in Mission Planner. RTK base station, I know is one of the big ones. You could spend like an hour just letting it run to the station. Set up all the parameters like driveway location, how wide you want to allow your snowblower to go. And when running missions, you can do a set of command set waypoints. Basically, while you're running, set a waypoint to make sure it goes down. And even while it's running, you can monitor your GPS location, how the RTK GPS is running, velocity, sensor readouts, and the telemetry radio logs. And also, if it does happen to go off course or it's about to hit the neighbor's mailbox, you can have manual override to control it back to your driveway to make sure no one gets hurt.
Alright, so next up we got our Gantt chart. A little bit on our Gantt chart. The chart on the left, we have it from basically today all the way to next semester. There's 3 key dates next semester. We want to have fully functional RC by around the first week in February. We want to have the GPS installed and testing by around 2 weeks later, so 20th of February. Then we want to have it autonomously running by spring break. And then the chart on the right, the green portion of it is the stuff that we've done, and the red is basically what we have left to do. So our bill of materials, we set up our bill of materials with a part name, vendor, and then our lead times, and how many parts we need. Nice little picture of the part, the cost of the parts. One thing to notice is that fully roll parts are about 6 week lead time, so we want to get purchasing those ASAP. And another thing is those fully roll parts are tariff based, so a lot of those prices may change depending on how the tariffs change. And in this slide, we have basically all of our new wiring parts, and the hood parts. And on this last slide, basically miscellaneous parts that we'll need. So for our estimated budget, the biggest portion of our budget is the GPS at about 70% of the budget. The control board is at 10% of the budget. The hardware miscellaneous parts is another 10%. And then the new hood will be the last 10% for a total budget of around $3,600. And that'll change depending on the tariffs. Any questions?
What type of setup is necessary before letting it run automatically?
What Garrett was referring to with the you have to let it sit for an hour. That's like the first time you set it up so that it can figure out where your house is relative to the US portion of the GPS infrastructure. Once you have that set up, you don't move to the base stations. It should be turn it on and it's running in 5 minutes. That's one of our design goals that we didn't have saved in here. From starting the engine to going, you can just 5 minutes, start a time with your tool.
Do you plan to have any obstacle avoidance just in case there is a person or walking?
It was initially in the scope, and our the review committee and us kind of mutually agreed that snow blowers are loud. This thing is loud. It's a Honda engine. And the obstacle avoidance sensors are all vision based, and we're going to be throwing powder into the field of vision of all the obstacle avoidance sensors. So we are going to rely solely on, manual supervision and the GPS navigation capacities for avoidance.
You get that picture.
Yeah,
It's a real authentic.
It's impressive.
Yeah. Real.
Back to how I interpreted his question. Like, how long or how difficult is create the manual? What it needs to do? Oh, it's not doing it on its own. You're right.
No, it's not like.
What's the GPS for then?
Make sure it drives.
Make sure it drives
correct. Because if it slips or something, then if you just give it input.
Well, I thought it was
10 forward.
Sorry, I came in a minute late. I thought it was autonomous. It's not autonomous.
It is.
It is.
Drive it one time.
Yeah, and then it'll drive it again.
And then it remembers this.
Yeah.
Okay.
It remembers it and it's able to correct itself back to the. It's not purely driving.
No, I get that. Yeah. But then, if you give this to a perfectionist, the first time they drive it, they're like, oh, I could have done that better. And then they drive,
Yeah, there's multiple ways you can set up the patterns or driving. Draw rectangles and say where, figure it out.
yeah.
Part of the difficulty for us is because we have a large physical object.
Yeah.
I think it's going to be easier, at least initially, to manually tell it needs to go forward or around. Because pick dots on every.
So this thing is big. I've seen it over there, right? So when you say follow the path, is the auger is the snowblower portion following the path, or is the center of the thing following the path?
You configure the geometry.
Because the important part is the auger.
Yeah.
Right? And that's got a huge swing.
Yeah.
Okay.
Yeah, you can. Arduino Pilot is it's like an Arduino IDE as well for the mission plan. So you do all of your configuring in that. And you tell it the front of the machine is 2 feet away from the sensor location, and the back of the machine is 1 foot from the back, and it's this wide. You tell it all of that, and it inverse kinematics its way to avoiding.
So it will remember its path and also its orientation.
Remember isn't the right.
Well,
it knows it and
but
it should be.
Yeah, but I'm saying the orientation too. Because because
that's why we have a second GPS.
Okay.
So it can figure out.
But yes, the auger being swinging out there is a big concern of ours. How comically front heavy it is.
So you have an e-stop on the top and on the right side. You need one on the left side too.
We've been thinking about that.
And maybe one on the front, just to cover your bases. I don't know.
Each person gets their own wireless e-stop.
Because if you're about to be run over on the left side, then you have to. You don't want to have to worry about reaching.
There are a lot of programmable software fail-safes. We're planning basically, if GPS signal lost for any reason, the auger stops. It's basically the first piece of rollover protection.
I saw one question, I don't know, this might not be a huge concern, but one thing I'm thinking is a lot of times when I'm snow blowing, depending on the direction of the wind, I know you can sort of erase all the work you did, if the snow blows back to it. So I was wondering could you theoretically have different maybe path presets so that to change the order depending on which way the wind's going or something like that, for the given day.
That is one of those things for the mission planner that said with commands, you can adjust certain timing and the location of shoot.
Okay.
For any of your electrical connections, if you actually want them to be weatherproof, I'd strongly urge you to use Deutsch series connectors. Probably most of your machine could get by with the DT series. But
I don't know why we didn't put a picture of those in. That was
Yeah, that's what's used mostly in industry, especially in heavy construction.
What's the plan for the machine knowing how far the chute is on? How does it know where the chute is? Sure. Isn't the Arduino map here?
Yeah, I think that's kind of what we were banking on a lot is the system. Knowing, like inputs given.
I know currently it's controlled by the knob on top of the controller.
Yeah.
So I'm pretty sure it just maps where that knob is located. Does it have some kind of sensor to show location?
Not currently, not.
That is also one of the parts of the relay that is broken. It's not.
Yeah, that's one of the things that we've been able to test that it electrically works with like a power supply, but not from a control standpoint.
Maybe that's something we're gonna have to figure out now that it's working on its own and it's not someone controlling a knob every time you want to. You have to have some kind of feedback.
Maybe I missed it, but how do you control like the level of the actual snowblower itself? Like as it's going over bumps in a driveway or something like that, so it's not gonna get like caught as it's driving, and like how would you account for that?
As of now, we're just not. Our first part, I mean, it's flat, and we're going with ideal flat rectangle for the time being. There's ways to you can have more advanced controls implementations in an RV pilot like mission reporting. So that would come down to like just manually bring it in adjustment.
For your budget, was that just a guess, 70, 10, 10, 10, or was one of those an actual quote and then you worked from there?
That was mainly a guess, 70, 10, 10, 10. We know that the biggest portion of our budget is going to be the GPS.
But the percentages have been changed based on our bill of materials to be correct. Initially, yeah, but by this point in the year, that's just a kind of percentage breakdown.
Does it get warm inside your box?
We haven't stuck on inside just yet. So. It also, the engine has like 2.5 running hours on it. So I'm not sure if it's ever been tested to that point, but that is a concern.
Just with your
You need
your wire tray melting.
Oh, I doubt.
Because it's for just a DigiKey,
that.
you know, it's not meant for external or heavy duty use, that wiring tray thing that you got in there, right?
That's something we'd have to look into, but I would shop that.
Yeah, with the hydraulics and whatnot, I didn't sure.
Is there an exhaust port with a fan or something?
Yep.